Alright, what this video is going to show is how to actually make your train move down the track. So I want to find my assembly view of my train. So right now I'm in assembly file, and then also what I'm going to do is I'm going to place a track. So I already have the track made. So what I need to do is go and find that track, and for me it's in a different folder because I've made this track before. So right there is my track, and I'm going to place it. And what I want to do is I can place this, and since we've originally had our body grounded, meaning that I can't move it, I actually want to take that pin off. So I'm going to right click on the actual body, uncheck the grounded, and I'm going to ground the track. If I wanted to, I could actually rotate my track, so I end up having this right up here, rotate component, grab, and I'm going to rotate that right there. Okay, so I have that track in place, and now what I want to do is actually ground that. So right click, and I'm going to left click on grounded. So now I can't move my track, but I can end up moving my train body. I'm going to place a couple more tracks. Oh, that's right, it was back in another folder. So what I'm going to do is place these couple tracks so that I can actually move it further down than just the couple inches that this track is. So I'm going to place 4 or 5 of these and constrain this. So the easiest way I found is just insert, and we'll go through and constrain all these. And now, so we're able to do this, so what we need to do is make it flush. Oops. Constrain, and I'm just going to flush up the faces, or the edges I should say. So that's pulling those all into place. Okay, now what I want to do is actually attach my train to the track. So in order to do that, like normal, I'm actually going to mate my bottom surface to the bottom side of the track. Once I can find the bottom right there. Okay, and I believe that the offset was, I think it was 0.375. Not exactly sure, but what I'm looking at right now is when I zoom in, I can grab this, and I notice that, see right here, the bottom of, or the edge of the tires are actually inside that groove. So it was 0.375. If it wasn't, what I can do, if I end up typing that in wrong, okay, I could end up changing this to 0.5. So that's just going, finding the mate that was in. So now it's saying that it's 5 inches above. I'm just going to adjust that back. Okay. Now what I want to do is get this facing the right way. And in order to do that, I'm going to take the edge of the train and constrain it to the edge of the side of the track. So now the groove is a little bit bigger than, this groove right here, it's a little bit bigger than the actual wheel thickness itself. So you just kind of eyeball it up. I think 0.75 was too much, yeah. So 0.6. Okay, so about 0.7 is fine. I'm going to apply that. Now, what I'm able to do is I've gotten rid of some of the degrees of freedom, but I can still move it up and down the track, which is what I want. However, if you notice that the wheels, they're spinning, but not necessarily how they would in real life. So what I'm going to do is I'm going to constrain that as well, and I'm going to use a motion. Okay? So I want to find out what I want to actually take place. And if you see that there's an icon, the rotation transition going on, or translation, sorry, and there's, you know, two wheels. So if I had two wheels next to each other, like gears or anything, or this situation where there's a circular object moving along a flat plane, okay, that's what I want. Now the tricky part about this is to actually notice what these arrows are looking for. So it's basically what direction you're moving, so this forward facing arrow, and which way you want it to spin. So I had a tough time dealing with this when I was first learning, because I would always want to do the bottom of the track, because, you know, this is the part that it's gliding along, so this is what it needs to interact with. However, what we're actually going to do is we're going to pick the wheel, okay, and you can kind of see right now how it's the arrow, it's spinning backwards, so I believe we're going to have to change that direction. But I've picked the wheel, so basically what wheel I want to spin, and then I want to end up picking this back face, because if you notice, again, looking at the arrow, it's starting from a stop position, so a flat surface right here. It's not the actual surface, this bottom of the track. If it was that situation, then this red arrow right here would be facing up. So it's basically asking, once you realize that, I mean, it makes sense, you know, what direction are you moving, and what do you want it, how many rotations do you want it to spin, okay? So I'm going to apply that, and if I check, what ends up happening is, see, now it's spinning, but it's basically doing the moonwalk, right? I mean, it's spinning faster than how it actually would in real life. So what I need to do is, first off, it's also spinning in the wrong direction. So I want to go back into that, so I can right click on that. Here's that constraint, and I can see by hovering over it, I can see that. I'm going to right click on that, and I'm going to edit it, okay? So here I have a reverse, so I just want to make it forward. I can hit OK. Now it's spinning in the right direction. However, again, it's too many rotations for how fast I'm pulling it. If we notice, if I go back and right click and edit this again, that it's this distance right here, it's asking, well, what is the circumference that you want it to spin? In order to give it one revolution, how far does it need to travel? And what this is saying, that for every inch this travels, it's going to do one revolution, basically. So what I need to do is I want to go back and find the circumference of my wheel. So again, that's the overall outside. Now again, most people want to take this 1 inch and go, okay, so I know that this is the radius, diameter is just twice that, so I'm just going to type in 2. But if you notice that this 1 inch right here is from the center of the wheel to the center point of this arch, and the radius of this arch is 1/8 of an inch, or 0.125. So I have an 1/8 inch on this side and 1 1/8 inch on that side. So what I need to do is I'm going to end up finding diameter. So because the equation for circumference is pi times diameter. So I have 1 inch plus 0.125. So I know that, so 1.125, I'm going to times that by 2, because this is the overall radius. So multiply that by 2. So it ends up giving me 2.25. So it's saying that the diameter of this wheel is 2 1/4 of an inch, and I need to multiply that by pi, 3.14. So 7.065. So it's saying that if I were to take a piece of string and lay this all the way around the outside edge, that piece of string would be 7.0625 inches. So I need to go back into Inventor, and this is where I need to type my distance, 7.065, sorry. Hit OK. Now when I grab it, notice how it's actually moving how it would in real life. So this one's working fine, however this back wheel, or not the back wheels, this other side still needs to be constrained. So it's just the same thing. Motion, I want, you know, a cylindrical object and a straight platform. Select the back side, 7.065. hit apply. Okay, check that out. Okay, so now when I pull this, my wheels are moving backwards, so I just need to end up going back into that rotation, edit, and then change my direction. So now both of my wheels are spinning in the same direction as if they would in real life. Now what I want to do so I can actually make this move on its own is I actually want to flush this back edge up. So I'm going to flush this back edge here, back edge of that, and I'm going to hit apply. Okay. So now what this has done is it's locked it in. Basically everything's locked. What I need to do is actually drive that constraint. So I'm going to right click here, and on this flush constraint, so the last constraint that I did, right click, drive constraint, and I have this pull down menu, and I can end up saying, you know, it's starting at 0 inches, where do I want it to stop? So it's saying that the furthest that this train is going to travel is 10 inches. Okay, so I know that my track's a little bit longer, so I'm going to go 4. And if I hit play, okay, you can kind of see that. If I rewind, oh, okay, I mean it's moving pretty fast. What I can do is say how many repetitions do I want it to go. So repetitions, I want it to start, end, so meaning it starts, goes from the start to the end, back to the start, back to the end. I'm just going to say, I'll just type in 8. Okay, total number of steps, increments 8 or an inch, and then from here it's just kind of playing around and seeing how fast you want it to make. Okay, so it's still kind of fast, and I'm going to stop this, go back to the beginning. Okay, and from here it just kind of takes some playing around. So by changing the number of steps or increments that it has, you know, I can slow this down if I want to make this even slower. Stop, rewind, 0.25. I can end up going here, and there I have a train. So now it's going to go there, stop back, and that's pretty much all you have for your train. So then you can play around making it fast as you want it to go, but that's the basics of it.